tutorial, we are going to be having a look at geometric sequences and focusing in specifically on what we call the general term. Now, with geometric sequences, you may have already come across recursion, whereby we can use our common ratio to multiply a preceding term to get the next term along in the sequence. Now, recursion works really well until you want to work with, say, the 30th, 50th, or even 100th term of a sequence. We don't want to have to repeat that recursion that many times, so instead we're going to use the general term to help us. Now, our general term for geometric sequences is T of n equals T1 multiplied by r to the power of n take 1, where our Tn is our term value, T1 is our first term, R is our common ratio, and N is our term number. Now, previously, when we looked at arithmetic sequences, we were able to find the common difference in between terms by subtracting a term from the term before it. This time, with our common ratio, we're going to be using division to help us. So to get our common ratio, we can take any two consecutive terms and divide them by each other. So if we were to take term 4 and divide it by term 3, that should equal the same as term 3 divided by term 2, which should equal the same as term 2 divided by term 1, and so on. So if you've been told you have a geometric sequence, you can take any two consecutive terms, divide them, and that will give you the common ratio. We're going to use this knowledge of general term to help us out with a few sequences to see if they're geometric and to calculate some unknown values. Now, for our first example, we have been given this sequence up on the board of 2, 6, 18, and 54. And we've been asked, if possible, to calculate what term 10 is. But firstly, we need to see if a common ratio exists between these given terms before we can go ahead and use the general term to calculate our unknown term 10. So to help us with this, I'm just going to label each of the terms we were given. So I've got term 1, term 2, term 3, and term 4. And I'm going to use them to help us find the common ratio. So I'm going to start off by taking term 2 and divide it by term 1. This is 6 divided by 2, which gives us 3. Now we're going to see if there's a second pair of consecutive terms that also has this common ratio. So I'm going to take term 3 and divide it by term 2 to get 18 over 6, which is also 3. So we know that therefore this is a geometric sequence. Which is great for us because we can now definitely go and calculate our 10th term. So we are going to utilize the general term to help us. And we're going to start off by seeing what variables we know. So we can have Tn, T1, R, and N. We already know that we're trying to calculate the 10th term. So I'm going to put n equals 10. And we've already calculated our common ratio of 3. Last thing we need to do is identify what our first term is, and that's going to be the first given value in our sequence, which in this case is 2. So our Tn is unknown. So let's go ahead and substitute those values into our general term. Term 10 is 2 multiplied by 3 to the power of 10 take 1. So if we pop that into our calculators, we can see that term 10 equals 39,366. Let's have a look at our second example, where we have been given the sequence of terms 360, 180, 90, and 45. And we've been asked to, if possible, calculate the value for term 8. Again, we're going to start off by checking to see if a common ratio exists within this sequence. So I'm going to start by labeling my terms to help me out. And I'm going to take any two consecutive terms and see what the ratio between them is. So I'm going to start off with term 2 divided by term 1, which is 180 divided by 360, which gives me 1/2. Let's try it again with another pair of terms. Term 3 divided by term 2 is 90 divided by 180, which is also 1/2. So we can confirm that therefore this is a geometric sequence. Again, we can go ahead and use our general term to help us calculate our unknown 8th term. And we're going to see what possible values we have. Tn, T1, R, and N. I missed out my R here. There we go. So we just calculated our common ratio of 1/2. So this is indicating to us that our sequence is getting smaller over time instead of getting larger like our previous example. The term number we're trying to find is 8, and we identified up the top here that our first term is 360. So we're left with finding our unknown term value. So let's go and put this into our general term. T8 equals 360 multiplied by 1/2 to the power of 8 take 1. Now if we put that into our calculators, we get term 8 equals 45 over 16. The final sequence we are going to be looking at today is this one up on the board of 10, 24, 52, and 108. And we've been asked to calculate, if possible, the value of term 16. So like we had with our previous examples, let's name our terms and use some consecutive pairs to see if a common ratio exists. So I'm going to start with term 2 divided by term 1, which is 24 divided by 10, which simplifies to 12 over 5. Let's have a look at our second pair of terms. Term 3 over term 2 is 52 over 24, which simplifies to 13 over 6. Now we can see here that these two common ratios that we've calculated aren't actually common at all. What that is indicating to us is that this is not a geometric sequence. And due to there being no common ratio between our set of terms, we unfortunately cannot calculate the unknown value of term 16. So in examples such as this, we simply say it's not a geometric sequence and we can't progress any further. I hope you've enjoyed our look into the general term of geometric sequences and have now been able to apply it successfully to your own geometric sequences problems. Remember, if this video helped you, press that like button and don't forget to include in the comments below any other video topics you would like to see covered. Happy solving!